Hello. Hello, Alirad. Thank you. Hello. Um, and hello, Jamie. Thank you. Hello, Yichan. Thank you. Hello. Um, okay. Hello, Angela. Hello, hello, Amelie. Excellent. Now we're cooking. Okay. Maybe you were all confused because you don't see the board up. Neither do I. I know we'll get to that in a minute. But and Mira, hello. And we don't see Mira. That's really why we're confused. I'm just kidding. Okay. Hello, everybody. Hello. Hello. Yes, Mira. Hello. Okay. I'm just kidding. Okay. Um, so we will have the board shortly and we'll have class shortly. It's a little bit of a funny day. I want to confirm a couple of things quickly. You had optional, no, you had regular lab 2 days ago, but it was on electricity. I know that, or electrostatics. We will, of course, we're gonna, I don't know, we'll hear from you about how that went. I know it's a totally new topic and it always, we learn in lab first, we get exposed in lab first, and then we discuss and unpack and so forth in lecture. And that's what we will do. But I do want to be clear about a couple of things. That new lab that you just did, that material doesn't appear on this exam. I'm sure you know that, on the exam that you're about to have. So therefore, for the moment, I'm not going to overly address that. I want to make sure we're okay on the exam situation. So let's confirm a couple of things. We all understand and we all agree that your exam, once posted, will be due right before class, right before this time, 3:05 p.m. next Thursday. That's when it's due. I'm just reminding or confirming, and you'll tell me in the chat, and I'm sure Professor Moses confirmed the same thing. Yes, okay, thank you, Jamie. I appreciate that. Okay, and we had said, and I'm repeating, that since you couldn't deal with, since lab was different on Tuesday, since lab was not about this, we had said that you could ask him questions during his office hours after lab if you could make it to his office hours, and maybe some of you did, maybe some of you didn't. We'll find out in a minute. I haven't spoken to him since then. I spoke to him at length right before. So we'll find out about that. But we had said that this was an opportunity, this period was an opportunity for you to bring questions regarding the practice exam from last week. And that remains the case. I'm a little scattered. But so the plan for at least the first part of today's period, the plan still is that you're going to raise and I'm going to address questions that there might be for no problem. Hello. Yes. No problem. Well, okay. Sorry. I'm looking at the chat. Yes. I mean, thank you. And no problem. Hello, Carla. Good to see you. And you're not, I'm still trying to complete my first sentence. Good afternoon, Sebastian. Good to see you both. No, you know how it is. Yes. I'm stuttering my way into a verb here. So bottom line, the plan for today, at least for the first half, is that once we get rolling here, you're going to raise questions. First of all, I hope you have your practice exam out in front of you, by which I mean the document. I don't know what work you have or have not done on it. I'm sort of hoping you've done a lot of work on it, but no matter what, I mean, the document itself, the questions, I hope you have that in front of you. The idea behind the period is that you're going to raise questions that you have about the practice exam, and I'm going to try to address them. I don't know that we're doing that the full period, but we're certainly doing that the first part of the period. I will I'll bring my board into life in a moment. I want to encourage you again, though, that the more specific your questions are about the practice exam, the more of them I'll be able to answer, and the more I'll be able to teach or explain or help you with this exam. The idea is for me to be helpful. The idea is not to play hide the ball. However, like the more helpful you are and the more prepared you are, the far more helpful I can be. Let me just warn you again that what I don't want to do, for a variety of reasons, I don't want someone to just raise their hand and just say, can you walk through all of problem 2? The truth of the matter is I might end up doing that anyway with a problem here or there. It's not that I might end up walking through a full problem. I don't have an objection to doing that of my own initiative. But I first want to prioritize specific questions that show some specific work on your part. And that can be handled specifically in a short amount of time. The truth is, as you can see already, once I start just going over and walking through a problem, as much as you might think that's to your benefit, I'm going to go down the rabbit hole and I'm just going to end up doing that problem and I won't be able to get to, and you know me, like it won't be efficient. I won't end up getting to any other like scattered details or micro issues that people might have. Okay. So again, I'm going to first prioritize specific questions. If you want to be scrambling right now and coming up with them quark speed to you, I want to first address specific questions from the practice exam. And I want to remind you one sort of last time that anything that I say here in detail is fine, is great. Anything Moses said to you, I mean, any answers we give you is great. And any amount of help that you give to each other, even once this exam is posted, is all great. But just know, any things that I don't get to today, if there's any questions in the exam that just like fully aren't addressed today, and then that means they're going to be fully unaltered in your real exam. Like your real exam is going to look a lot like this practice. Where it's going to be tweaked the most is wherever we talk the most about it. I hope that makes sense. So either way, you're getting a benefit. Is like you're either getting some advanced help or you're getting advanced lead time on doing it. Your exam, again, will look remarkably like the practice exam. Remarkably. If you really, really are on top of the practice exam, you should be looking out for changes and variations that force you to think you should be looking out for changes and variations on the real thing. But you should still know in advance that if you're completely solid on this practice, you will be solid on the real thing. Okay, that's enough introduction as usual. One last logistical thing I want to good afternoon. Good afternoon. Awesome. Good afternoon. Taco Rub. The one last thing I want to confirm with you before. So again, as soon as I shut up, we're going to turn the ball to you to be asking me specific questions. It won't be all period. There will also be time this period to work individually based on what's happening and maybe to get ahead on the material. But first of all, just because I don't see any videos today, I'm just saying, and because you don't see a video of a board, can I just get electronic thumbs up? Are you do we understand what's about to happen today? Are we on the same page? Okay, great. Yes, whoa, she's like outside. Okay. Oh, and then okay, great. Thank you all. I totally saw that. And I have to admit, I'm a total sucker for those animated reactions. I'm such a adolescent. Okay. Which is not an insult. Except to all adolescents in the world. Okay, great. So we're all clear. So then the one thing I want to confirm, because for some reason I noticed in your Google Classroom, for some reason, I never formally, I apologize, I never formalized our logistics. It doesn't look like. Remind me, we all know your exam is due a week from 20 minutes ago. It's due at 3:05 next Thursday. That we all agree. Can you remind me, what did I say? I'm afraid to ask this. Please remind me honestly, when did I say it would be posted? Okay. The 28th. Thank you for your honesty. Thank you. Okay, that's what I thought. Hold on, right, because what is the 28th? Saturday. Okay. Odd, but okay. I'm just making note of that right now. Hold on a second. Okay. That is what I thought, but because it's a little unusual. I know why I did that, but it is a little unusual, so I wanted to confirm with you. Okay, and I'll try to put, all right, so the 28th. And that means okay, sorry. I'm just making a note of this. Okay, Saturday the 28th. Okay, and I'm confirming now, if I said the 28th, which sounds like I did, what I generally say, tell me if this differs from if I didn't say a time, what that generally means to me is no later than 8 p.m. I will try to do it a lot earlier. I mean, I'll tell you, I will try to, but whenever, unless I said something different to you and you could tell me right now, whatever day I usually tell classes, what I say is I post no later than 8 p.m. And then the whole idea is I don't want to ruin your whole weekend. Like you still have your Friday night, blah, blah, blah. But obviously I want to give you the weekend to do it and Monday night and all that. So that, let me just look in the chat right now. The 20, okay. So unless you tell me otherwise, I mean, unless I specified a different time, which I don't think I did, what I'm saying to you right now is you can expect to be no later than 8 p.m., but it might be a lot earlier. And don't be freaked. If it's earlier, that's just gives you more time. It doesn't mean you have to start it earlier. But okay, is it again? Are we clear? And that doesn't contradict anything we've said so far? Correct? Are we like I'm saying? Okay, thank you, Mira. Thank you, Takarub. Okay, all right. So we're on the same page with that. So that means, and thank you, Carla. Sorry, and thank you, Sebastian. Thank you all. All right, awesome. Okay. So what that means is I'm going to pause for a second. And just to be honest too, I mean, I know I'm always the reason I'm a little bit spazzy right now is like I don't know if you've been reading the news, but I live in Maine and Maine's a little bit weird right now. I mean, everybody's fine in my I'm not trying to invoke some, I mean, we're all safe, we're all fine, but it is a little bit but we're close to what's so for example, everything is locked down. My kid's school was shut down today, so he's been here all day. So I'm just explaining that's why I'm a little bit like it is a weird time for us all, isn't it? But and if you don't know what I'm talking about, you look in the news, whatever. But it's like strange. But it's not like, but I mean, you guys deal with, I mean, I know it's not the first, it's hardly the first time that any of us in this room are dealing with some kind of weirdness in the world. So what I'm going to do is pause for a second. I'm going to get my board up and I'm going to wait for questions about the practice exam. And I'm literally going to wait for a second. It's not a competition or anything like that, but I'm even going to ask, you can use, you can raise your hand, of course. You can use the chat. You can use the direct chat. But the reason I'm going to wait for a minute, honestly, well, is to make sure you have your exam out in front of you. But also, I'm going to wait until I get like 2 or 3 questions. And then I'm going to then I'm going to try to I'm going to be conscious of the order I answer them in. And I'm not answering the better questions first, so don't take it as a value judgment. But I am sort of interested in being efficient, if you can imagine. So I'm going to wait till there's like 2 or 3 questions, and I'm going to look and like the ones that I can sort of feel like I can answer more concisely without going down a rabbit hole. I'm going to go for those first. Okay. So your job right now is to come up with areas of concern from the practice exam. And the more specific you can make your question, your job is to control me. Try to ask the question in a way that would keep me from sprawling for hours. And you can also cut me off. And please, either you can raise your hand or you can put it in the chat or you can put it in the direct chat and bear with me for a second while I get the board up and going. But that's what's happening now. Okay. So it would appear so far that there aren't any questions. That's okay. That's maybe that could be very good news, obviously, but it could also be a slight concern. So here's what I'm going to say. Because again, I mean, I don't mind. Well, I mean, yeah, I dare not speculate. All right, like if there's no questions, of course, that could mean that you're all totally set on the practice exam, and that'd be great. And I'm not saying I have some experience-based reason to believe that well, if you don't have any questions, it can mean one of three things. It can mean that you're truly set, and that's great, and we can move on to the new material. And I'm not saying that as a threat, even though I sort of am. And we can move on to the new material, to the electrostatics and all of that. Or it could mean you think you're totally set, and maybe you're not. Or it could mean that you're not set yet to know where you're not set, which would probably be my guess and would be the realism. Here we go. Someone's saving. Okay, someone is saving the ship. Because I see one question in the direct chat, and I got to say kudos to that person because they might have just saved the whole class. I'm not laughing, but I totally am. Wait. Okay, and it's a very specific question in the direct chat, which is great. Oh, and now we're okay. Now we're okay. This is good. I've now got two. You might have both just saved. Okay. We now have two questions in the direct chat and they both look like very similar questions, which is good. And one of them even uses the word we, which tends to imply that like there's been some collaborative something, which is good. So okay. Yes. And in fact, I'll even, so basically three people, hold on. Okay, hold on. So now I have three questions. So thank you. And thank you for, so now actually let me pull up mine and look, and I'll tell you what the questions are in a second. Hold on. I'm going to make okay, you totally just saved the class. It's almost like you guys have been professional students for a while and like know how to do it. It's good. So I'm scrolling to just see these three questions. Which one is if they're all the same, which they might actually be. Page 10 and 11. Wait, page 10 and 11. Hold on. Page 10 and 11. Oh, from the spring midterm. Oh, interesting. Hold on. Okay, I'm going to look quickly. I'm going to say right now. Okay, so two people are asking questions that are very identical about our practice test, which is good. And then someone's asking one about the old one, which is fair. I mean, and anything is fair game. And obviously any old videos or any old documents that you find to help you study, all the power to you. That is definitely not cheating. It just makes me feel like I've been doing something for a living for a while. And so indeed I had left up the a midterm from the spring or a practice midterm from the spring. I had it up there until I had your most updated one. And I left it there so you could have more practice and stuff. So someone's asking about that, about the old one, which is totally fair. But let me look for a second to see if if it's worth your time to worry about or not. So give me a second. But that's a good. Hang on. But again, and I mean this on the fact that someone's asking about the old practice exam, that hopefully that means that they're like doing so much that they not only looked at the current one, but they also for more practice looked at the old one. And that's great. But with all due respect, also, let me just say, if that's not the case, any of you, if you're only looking at the old one, like look at the dates carefully. If you're only looking at the practice from spring 21, that would be a mistake. Like definitely the more accurate representation of what you're about to do would be the one that says fall 23 on it. Like that's the updated version. So if you only can do one thing, do that. But sure, if you're doing more than one thing, oh, okay, I see. Okay. Great question. I commend you. Yes. So number one, and I hope people are fine. I know I'm just talking in my head here. So one person in direct chat asked about pages 10 and 11 in the spring version of this midterm or whatever the spring. And they asked, is 10 and 11, like, what's the deal with it? Is it extra credit or what? And great question, because yes, 10 and 11 are not part of your test at all. They weren't extra credit at the time. They were very, very real, but we used to do this course differently. There was like, whatever, it was part of the way we used to do the course. So that's a perfect example. If you guys look at the old test for more practice in addition to the contemporary test, that's great, but absolutely just ignore pages 10, 11. There's nothing like that on your test. That's a promise. And that's one of the reasons I keep trying to update and make sure we're all okay. So great. And maybe the person who's asking this, just confirm in the direct chat that you're hearing me, like, yes, you can completely ignore pages 10 and 11 of the old test. That's why they don't appear in your fall 23 practice. But that's it. Okay. Okay. Cool. Great example of a concise question. I'm sorry I took so long with it, but okay. Now, 2 other people in the chat are asking about our fall 23 practice exam. They're asking about that. And they're asking about part 3, which is very appropriate because the people that are asking about part 3, so I might share screens now in a second. If you got to noticing part 3, sure, you would notice that part 3, i.e. pages 8 through 10, for sure. That's the newest part of your exam. Like, that's the part that you don't have a ton of practice with. I guess we had talked about this. So, and it's definitely on your exam. Like, if you were to focus your attention anywhere, it would be there for sure. Yes, and it's like totally your class. So a couple of people are asking about that. I will address that. Pages 8 through 10, part 3 of the practice exam. I might share it on the screen in a second if you need to screenshot, but let me just see what specifically did they. All right, part 3, a question. Okay, and one person, thank you, is specifically saying question B. So that focuses me a little bit better. That's good. So let me go there. Oh, okay. Yeah, I can start with that. All right, hold on, someone's coming. All right. Okay. So what I'm going to do for a moment, it's always questionable. It takes a little, I'm going to switch screens so that you can see exactly what somebody's asking about. And also, frankly, so that if you're watching this as a video, you know what's going on. So you can screenshot or whatever. So hang on. So I'm going to switch screens. Right. Okay. So the problem we're talking about in general is this one right here. Right? Collection of, and the whole purpose of this whole problem is it's how you ultimately show me that you can go from your understanding of one individual harmonic oscillator to a bunch of harmonic oscillators, and how if we arrange a bunch in a very deliberate, specific way, then we ultimately will create the immaterial, unthingy type of motion called wave motion, right? That's the whole idea of this problem, is to show how we can get from a bunch of particles to a wave. That's the point of it, and it's a walkthrough. And I'm going to honor the fact, like, first it asks you to do a whole diagram, right? Maybe I could talk more about that, or maybe I won't. But what someone's asking me about first specifically, they're asking me about here, part B, how you would get the spring stiffness of each harmonic oscillator. You will solve for one value to apply to all, show all work. Okay, I guess because I'm trying to be concise right now. Again, depending on our time, we can circle back and I can expand on this more. But if I'm trying to be concise and actually honor people's question, my fast answer to this is, and I have to be very careful. Like, I'm telling you, like, what I would do. Right now, I'm not about to write it down. So whatever you do, whatever I say, you have to do the 5-step method, and you have to expand it out and show your understanding, all that. But to answer your question right now vocally, what I would do for this problem, for part B, determine the spring stiffness of each harmonic oscillator. What I would realize in my mind, and I would write down as a step 3 GDP. As a step 3 GDP, I would write omega equals square root of K over M. Right? That's what this comes down to. Omega equals square root of K over M. I would take a moment to explain how that's true, or why that's true, or what that means. Or if somewhere earlier in the exam, I feel like I've already really explained it, I would refer to an earlier part in the exam. And again, if someone wants to ask me a question in 10 minutes about that, I will answer. But I would write down as a step 3, we already step 1, you have a diagram you'd refer to above. Step 2, the question is, what is K? K equals question mark? Like that's what's being asked here. K as in our original K, as in spring stiffness, as in Hooke's law, right? So the question here is K equals question mark. And then for step 3, GDP, the first thing I would say is, well, for an individual harmonic oscillator, omega, the angular frequency, always equals the square root of K over M, where K is stiffness and M is mass. So I'd write that down and I would explain it. I'm just saying that again. I would definitely explain it or refer to explanations above, and explain can mean why, it can mean how, it can mean what its implications. It's like anything you think you understand about it that can show me that you're really in this class and that you're not just copying and pasting from the wide world web or the world web, right? You would explain, but anyway, omega equals square root of K over M. And then, because why am I even saying that? Well, then step 4, PAW, like here in this problem, if I scroll up, the equation that was given to me here, here's the equation that describes this whole assembly of oscillators. Well, and maybe I should start writing down in a second. If you're familiar with this type of equation, like this equation, put numbers in for values to tell you how to specifically draw this specific situation and to allow you to get specific. But the point is, the general equation that this is y equals a cosine omega t plus kx, where, and in fact, it's the thing that was on my screen like 10 minutes ago, like that equation that was, so if you scroll back the video or whatever, it's the thing that was on the screen until it's that equation. And mind you, the K in that equation is a different K. It's angular wave number, not Hooke's law K. See, I'm going down a rabbit hole even when I'm not going down a rabbit. So my point is, what I'm trying to say is this equation is making clear that here in this case, in this problem, step 4 PAW, omega equals pi over 2 radians per second. I mean, that's the key here. Omega in general is square root of K over M. But here, omega evidently equals pi over 2 radians per second. And therefore, then, so omega equals square root of K over M. Omega is pi over 2 radians per second. M was given right up here as 10 kilograms. So another piece of strategic advice, what I would, and maybe I should have said this first, omega equals square root of K over M. Here we know omega, but before I even plug in numbers, if you're really listening to, right, if you want to get the benefit of the fact that you're here right now, if you want to be slick and really advance yourself as a physicist and like really show that you're getting physics taste, what you would do in the exam is actually, before you even plug in the numbers, you'd write omega equals square root of K over M. And then since you're solving for K, you would first algebraically rearrange that statement. You would always postpone numbers as long as you can so that you have physics, raw physics going for as long as you can, which has a number of advantages, not the least of which it shows that you're fluent in physics, but another one of which is I can see the physics, I can give you full credit for this correct physics, and even if, quark forbid, you like somehow plug in a wrong number from some earlier part, or you make a calculator error or something, by the time the numbers come in, we're down to like the last mini micro steps, and you're going to only lose like a point or two, right? So sidebar, the big strategy always for all this stuff is you postpone numbers as long as you can, and that's what physicists do. Okay, so you would write omega equals square root of K over M. You would rearrange, like i.e., you square both sides, so you have omega squared equals K over M, multiply both sides by M. So now you have K equals omega squared M, right? And again, I can, if someone at the end of this whole thing says, that was all great, but actually, could you write it down for, I will, like, but I'm just trying to, whatever. So you would write down, K equals omega squared times M. That's not a formula. It's not something you should memorize. It's not something that's given on the front page. It's just a result that's helpful for this situation. K equals omega squared M. So now you've got an omega to plug in. It is pi over 2 radians per second squared. And you got an M to plug in, 10. Multiply them together. And you'll get an answer for K, last bit of, and I don't mind saying what it is if I can do it in my head. I'm going to, this is an example where this will be on your test. Like, it's a great question that someone's asking. It will be on your test. Will I change the numbers or tweak it slightly now that I've talked about it? Sure, but not enough to throw you off if you're understanding what I'm talking about. So you would say K equals omega squared times M. Omega is pi over 2. So squared is pi squared over 4 times M is 10. So pi squared over 4. Now, would you leave that as it is or not? Well, it's asking for a stiffness of a spring. Ideally, if it really wanted to be as unambiguous as possible, where am I? It says in newtons per meter. I'm back to the question now. It says in newtons per meter. Ideally, if I were a perfect human being, which, I plan to be in a couple of weeks, if I were a perfect human being, I might have even said approximating to 3 significant digits or something like that. If I ever mention units or number of significant digits, it's not to intimidate you. It's not to make you get all squeezed by the exact number of significant digits. It's not, if I ever mention units or significant digits, it's because I'm actually saying that what we want here is a measurable, relatable, approximate number rather than an exact but non-relatable, non-measurable number. In other words, the fact that I said in newtons per meter, or if I were even better, if I said to a certain number of significant digits, I'm signaling you that I want you to take that pi and approximate it as 3.14. Like, that's not always true, but in cases like this, where we're thinking about something physical and experimental, like pi is not something you can get in the lab or relate. So just to finish this up, for better or for worse, if I'm saying the answer is if I'm saying that K equals omega squared times M, and omega squared was pi squared over 4, that's really like 3.14 squared, which is like approximately 10, like over 4. So I'm saying this approximately, but so that's like 2.5 times 10 for the mass, 10 kilograms. So your answer for this will be about K equals 20, approximately, because you chopped off digits, and you would say like approximately 25 newtons per meter. And by the way, that is the answer to this one. Like, if you had the exam right now, that'd be the answer. And if you showed all the work that I just said, you'd get this one right. Last thing, and then I will shut up. But I think it was I think this is a good, if we can keep the question sort of like on this level, I think that's good. Please be mindful too, if you were following everything I just said, or if next time you want me to write it down, notice that it's some point in my analysis, some point in your 5 steps, somewhere in the middle of step 4 or right before step 5, you literally do change the equal sign to an approximate equal sign. You do, because we're just like sometimes we're using triple equal signs and other times we're using double. We're being more accurate if we say here, if we acknowledge that our answer is not exactly correct. It's not because you're saying it's a guess. And it's not because you're saying, you're just saying, I recognize that when I said that pi was 3.14, I was chopping off digits. So my final answer is chopping off digits. It's not saying it's random. It's just saying it's approximate. And that is the correct scientific thing to do. Okay, I'm going to pause for a second. So first of all, I think that was a good question. Let me ask before I go. Okay. So I'm looking in the chat. Can I do the diagram? Okay. I assume that means of the whole thing. That's a fair question. I'm just looking at the direct. One thing I want to say too, that now that I have answered one question, the person whose question it was, I would love it if at some point, if they could privately say like whether that worked for them or not, or if they need more, like, for example, if they say, or someone says, well, actually, could you back up and draw part of what you just said? I could do that. So I will. But someone else in the direct chat is saying, can I do the diagram? I'm assuming they mean the whole big diagram that's asked for in part A. And probably the answer is yes. Probably the answer is yes, although that is a big thing. It'll take me a while. So I probably can and will, but I'm first going to see if but you see, that last question was a nice, short, tight question. It still took me a while. So I'm first going to see if there's things that maybe I can do in less time first. But yeah, you can remind me. I probably can do the diagram. I will definitely say that diagram is in a bunch of videos that we have for this class. But right, it's not labeled. Yeah, I probably will, or at least I'll do part of the diagram in a minute. Let me just see what other questions are going on here. Okay. Thank you for direct chat person for tying the loop on that. Okay, good. And let me just see also the other questions part. Okay, I'm looking at the other questions. Wait. Okay, so here's good. Someone's asking in the chat, when I ask for approximate in a question, we should utilize triple equal signs. No, I'm not saying that. It's a good question, but let me be clear. No. If I ask for approximate, or if in any way I signal to you that you should approximate, i.e., when you change pi into 3.14, or like you change like square root of 2 into 1.414 or something like that, I'm saying then you should change your equal sign to squigglies, not triple, like double squiggly, and definitely make it clear to me in the chat if you understand what I'm saying or not. When I mentioned triple equal sign a minute ago, that was an analogy. I mean, I'm saying triple equal sign is another thing we care about. You should use triple equal sign. You need to use triple equal sign whenever two things are equal by definition. When one thing is defined to be equal to another, that's when we use triple equal sign. So I'm basically saying there's like 3 different types of equal sign. There's triple, double, and double squiggly. And yeah, so that's what I'm saying. I don't know. So maybe tell me if that makes sense or not. But now, okay, cool. All right, on the diagram, I will at least do part of it. Maybe I'll do that in a second. And you can keep reminding me if I lose track. Yeah. Okay. So someone's actually saying, I'm glad someone has the guts to, yeah. So someone's now saying in chat, actually, for the next time I answer questions, the next ones, could I please actually write it down? Because it's easier to take notes. Fair enough. Yeah, you're right. I don't know why I needed to be told that. Yes, I will. Now that there's at least one confirmation that would make a difference to you. Yes, absolutely. And then, so I'm going to switch screens. But will I be taking off points on the exam if we write double equal sign instead of triple equal sign? I mean, that's a very fair question. That's like one of those things. So if like one time, that's one of those subtleties which they build up over time. To be totally honest, things like double equal sign or triple equal sign, if you like 1 or 2 times use a double equal sign where I think you should be using a triple, you probably won't lose points. But this is probably not, if it's like 1 or 2 times. And if there's any ambiguity, like really, I really do believe, I don't mean this as a cliche, but like in exam grading and in teaching stuff, I really do believe like innocent until proven guilty. And I really do believe like tie goes to the runner, which is a baseball thing that basically means the same thing. So like if one of you is like doing an exam and it's a good exam, and then like somewhere on page 4, there's like this double equal sign that I kind of feel like I would have made a triple, but it's like on the, and it's on the edge, or it's not 100%, that I could sort of see it both ways, I'm going to let it go. But what it is, when I'm telling you things like double equal sign and triple equal sign, what I'm really, partly I'm telling you, yeah, that's not a minimum standard. That's the kind of thing you start worrying about when you're really, well, it separates the excellent from the very good. And so it's more goes the other way. It's more like if right at the beginning of your exam, especially at the beginning, if you're really going to town, really making clear efforts to like use different colors, to be really neat in your presentation, to be really eye-catching in your presentation, to really separate English over here from math over here, from diagrams over here and stuff like that, right? And especially at the beginning of the exam, you're going to effort to show that you've picked up on subtleties in this class, like you use triple equal signs where they are appropriate, usually in step 3, usually where triple equal signs are very appropriate is in step 3 jjP, right? So if you're using triple equal signs where appropriate, and you're making a clear effort of shifting to approximate equal signs in step 4 where appropriate, it's not so much that you lose points if you don't do that. It's that those are like pro tips for how, I guess that's really what it comes down to. What I'm trying to do today, because I know it's boring to sit here and like walk through an exam for the 50th time, but kind of today it's kind of like pro tips, like all these little things that I say, if you catch them here today and you deploy them, in your exam, especially in the first few pages of the exam, what you're doing is really bringing me on your side. You're increasing your chances that you're really showing me that you really have an excellent exam and you've been excellently paying attention, that you excellently are getting fluent in physics. So I guess, I know, again, I'm taking too long to answer a simple question, but it is true. It's hard to predict exactly where I'm going to take off points when. It's a funky kind of exam to do. When it's all take home and you can all help each other, stuff like that. Those, I know that at some level it seems a lot easier than other exams, but those of you who are really paying attention know in the back of your minds, like, but if he's doing all this, there's going to be weird, like somewhere he's going to take off points that I'm not expecting. Like if people have gotten 70s in the past on exams where they can help each other, there must be something intense going on in the grading. And you're right. Like, and if you're thinking, I can't predict what, so any little thing that I'm saying here, like triple equal sign, it's not like you should be worried about losing points if you don't do it. You should be taking it as good strategy and advice for how to push your exam over the edge and separate it from other people's and grab my attention from the start and convince me that you really know what you're doing. I hope that's sort of, okay, like all of these subtleties are like that. They're pro tips. And so the person who asked me that, totally fair, but maybe if they could acknowledge later in their direct chat, if that makes sense. But now I'm going to switch the screens before I'm going to go to start taking notes so I can help. Oh, okay, cool. I'll be using, that's awesome. Okay, I'm not going to say who the person is, but I love the fact that the person just wrote, thank you, got it. I will be using the pro tips. Now that is a pro thing to say. That's what we want to hear. That is awesome. Okay, and yes, so, and okay, and I know that person is speaking for many, not just they self. Okay, so wait, I'm switching the screen. I'm switching the screen. Taking what I'm going to do now too. In honor, I'm going to try to draw that diagram that someone's asking for. If I can get my, if I can win my battle against technology, which is such a stupid thing to say. I hate when people say that, especially if they're physics professors. Just bear with me for a second. Okay. I mean, literally, like we always say, like, oh, wait, I have a bad relationship with technology. But like literally, fair enough. Like we all do in a way, but like, do we really mean that when we say that? I mean, can you imagine a caveman and it's like time to eat, and then like can't get she or he can't get the fire started, and they're like, I have a bad relationship with technology. I mean, like you got to eat. Like it's not technology, it's your work. Anyway, whatever. Okay. So I don't know what I meant by that either. All right. I'm going to try right now. I love Roland's avatar. That's great. Sorry, I just switched screens and I see it now. Okay. I totally want to see that Wonderland game, even though I'm not a 2D platformer kind of guy. I definitely like anything that refers to Alice in Wonderland. Okay. All right. I'm going to try to draw that diagram. I'm a little afraid to draw it because I don't want yours to be exactly like what I do right now. But yes, I'll start it. I'm drawing some of it is what I'm doing. And you'll notice. Let me think for a second. Hold on. Right. Okay. Yeah. Okay. I'm drawing some of it. And I'm going to be this is excerpt. Especially notice. Oh, actually, it says. Wait a minute. Yeah. Okay. Yeah. So you notice your exam says you got to draw at least 6 oscillators. There's a reason for that, which hopefully you'll see come to understand by the time I'm just Oh, wait, you can't see. Wait, can you see? Hold on. Can you see my? Oh, yeah, you can. Okay. I'm not going to draw all six. Your rule is that you have to draw six. I'm not drawing all six. I'm drawing some because I don't want to give away the whole farm. And I'll tell you this right now. This is an example. If I okay. Like if I drew all six or nine for you right now, then I would have to change the numbers in this, and I'm not sure I want to. I might. But if I don't draw all six and I don't give away this whole farm, then maybe you have some confidence to believe that the problem will look very similar. And this is a tricky enough situation that, like, yeah, I'm not even sure I want to change. Anyway, so bear with me. But here's an example of what you would draw. And there's more to it. Hold on. And, if you want to be really clever or show that you're adaptable and flexible of mind and spirit, you might, I'm having these springs like hang down from a ceiling. You might have the springs on the floor and have the masses on top of them or something. I mean, there's other ways you could do this that would, but the way I'm doing it is this. Let's say, hold on, let me just look at more details I can give you. 1 second. Oh, wait, no, wait, change one thing. Sorry. Yeah. Okay, I will. Okay, this is a very fair question. What else can I put in here? What else is okay? Um, okay, I'm going to explain what's going on. I'm going to explain what is here, and I'm going to explain what's not here. So in a way, I'm sort of pleased that someone's like, hopefully this will help you. But what will also help you is if you go home and think about exactly what I left out and why or what, then you really know you're set for this. So this is the type of drawing I'm talking about, where you have a bunch. Oh, I don't know why something got erased. Where you have a bunch of vertical springs lined up in succession along an x-axis, right? And they're equidistant along the x-axis, and they're identical springs. They all have the same mass. They all have the same stiffness. And a couple things to notice. And they're like arranged. So each one can oscillate along the y-axis, and they're arranged along the x-axis. The y-axis is very definitively and like deliberately going through that first that it's going through the first spring you see, which from here on in, I am not going to call the first spring. Like you could put this somehow in your, like, this is the 0th spring. This is the first spring or oscillator or whatever, the first harmonic oscillator. So you could do something like this in your labeling. This is the second. Why am I being picky about that? Like you'll notice that the one that I'm calling the 0th oscillator is literally at x equals 0. It's like on the y-axis, or the y-axis on purpose. I drew through it, right? So the 0th oscillator is the one that's at x equals 0. And then the first oscillator is at x equals 1, or 1 centimeter in this case, et cetera, right? So that's all like on purpose. Also notice in the picture, I put the letter, like the instructions say, like I have M labeled, I have K labeled, I have A labeled as letters so that once I start using those letters, those constants and variables in my analysis throughout the problem, like it's clear from the picture what they mean. That's the purpose of the picture. But then at the bottom, where I happen to know numerical values for them, then I write them out. Like, okay, M equals 10 kilograms, etc. Just like note or pro tip or whatever. What I didn't do was put the 10 in the picture. I put M in the picture, and then I comment below, oh, by the way, in this case, M equals 10. And part of the reason for that, again, is we're always like postponing, we're always like giving numbers kind of second class status, because we're trying to create physics that would be true for, we're trying to create a diagram and do a bunch of analysis that will be true for whatever numbers we ever would plug in. That's like the idea, right? Okay, so the letters are labeled, and then where applicable, the values for the letters like are given at the bottom. But now note a couple of other things. Notice one thing I almost messed up. I put the x-axis like way below in my excerpted position picture here. Why did I do that? Is yours going to look like this? Is your x-axis going to go through no spring whatsoever? I don't think so. I think, but the reason I did it here is because I didn't include all the springs. I think the x-axis for this picture is the value y equals 0, right? Like that's what an axis means. Like wherever, if you're ever on the x-axis, that means your y value is nothing. So the x-axis here should represent the equilibrium location for each and every one of these springs, right? Like what I'm really trying to say for the pros that are listening is that like, if I kept drawing springs for a long time, like I would eventually get to some springs that are below the equilibrium. And I get to at least one or something that's like right on the equilibrium, right? Like the springs are arranged ultimately, I think in some kind of, I don't know, cosine curve, right? Like who's with me, right? That was a rhetorical question. Now I think it takes a number of springs until you actually see that. And that's where the instructions come in. I haven't drawn enough yet for us to actually swoop back and see but what I'm trying to do without giving away the whole farm, but with giving away a lot of the farm, and I don't know what that expression means either, even though I live in Maine, without giving away the whole farm, like the amount that's between the springs, like the difference in where the springs are at this one snapshot. This is a snapshot in time, right? This is any snapshot in time. The differences between the springs' vertical position is the difference between the stage of the cycle that each one of the masses is in. Like, in other words, what I'm really trying to say here is that these masses should be separated by a certain chunk of the cycle, and that certain chunk of the cycle is not random or arbitrary or just a guess or something like that. It's like actually told to you by that equation. How much these things are differing in phase is literal and exact and is being told to you by that equation. Now, I might change the values in that equation, or I might not, but I will remind you right now, what I'm getting at is that 2 pi radians is a full cycle, right? So if somewhere in that equation, we believe that some aspect of that equation is telling us how many radians we advance in cycle per each meter that we go over it in the x-axis. And I do believe that. And I probably will be clear about that in a minute. But then what I'm trying to say is, if the very first spring where it is, if the very first mass where it is, and the next, if the next spring were sorry, if the next spring were at the equilibrium position, and then the next spring below that, next to that, were at an equidistance below the equilibrium position. In other words, if this fourth spring, say this fourth spring were not lower than the third one, but we were already starting to come back up by this fourth spring, if this fourth spring were at the same place as the second, I'm saying fourth and second, I really mean the third and the first. If spring number 3 was exactly at the same height as spring number 1, assuming the one all the way to the left is called 0, then if you think about it, if you understand what I'm saying, then you would realize that each one of these springs was separated by a quarter cycle. Right now, I'm being careful and I'm not drawing what I'm saying right now because I don't want to mess up the correct. This is the correct drawing. But in order to understand the correct or the correct excerpt of the drawing, in order to understand it, contrast it in your mind with what, for example, I usually draw in the videos and what probably is in your notes somewhere. Like usually in the videos and in your notes, like by the fourth mass, by the mass all the way to the right edge of this page, I've already come up. And that means, if I've done that, if you think about it, it means then if the last one's already come up back to where spring number 1 is, then that would mean that spring number 1 is at equilibrium and spring number 0 is at amplitude and spring number 2 is at negative amplitude. That would mean that each one of these is separated by a quarter cycle. And what is a quarter cycle? A quarter cycle is pi over 2 radians. It's pi over 2 radians. I don't think I'm being articulate. I'm saying this. I'm saying okay, wait, hold on. This is me talking now. This is not in response to, this is not like an exact answer to an exact question. I'm just trying to explain something right now. The entire collection and I'm looking at the, hold on. I'm still trying to answer this, but I'm looking at the chat at the top. Oh, yes. I mean, to the direct chat person, in terms of the counter example that I'm trying to explain right now, yes, I think. Let me go back to that. Well, the person in direct chat is saying the top would be our positive frame of reference and the bottom would be our negative frame of reference. Yes, if I understand what you're saying, wait, the top would be our positive. I'm not totally sure what you're saying, but I think the answer is yes for the counter example that I'm drawing right now. So bear with me for a second. So for example, if okay, so sidebar, and again, what I'm trying to do is to show you all what exactly is true and important about the actual correct diagram, but I'm trying to show it to you by looking at a counterfactual. Like I'm trying to contrast it with what would be true in a different, with different numbers or different. I'm trying to really show you how to translate the numbers to your picture So look, in the example that we usually do, like in the videos, when I'm first explaining this and stuff, I usually use an example where angular wave number, K, is pi over 2 radians per second. Remember, pi over 2 means quarter cycle, right? Because 2 pi radians means full cycle. So pi over 2 is like a lot easier to draw and think about. It's like, okay, so think about this for a second. And then because this is an exam, like I'm making it slightly harder in your exam problem. So even though I'm like giving it all away right now, like, even just making this translation or thinking about it is like hard enough and important enough to be worth it in my mind. So look, in this example right here, which again, I think you would see on the videos and stuff. Okay, in this example right here, that would be the y-axis, right? And honestly, I believe I could say with some certainty that this would be the x-axis. Like in this picture right here, notice 2 of those masses are on the equilibrium line. I mean, they're at equilibrium. And then you got the mass to the left of one of the ones that's on. And so I'm calling this one again. This is SHO number 1, right? It's very confusing. Like, remember, the one that's on the y-axis is really SHO number 0. So it really makes it harder to talk about. But and this one's number 3, right? So notice that number 1 and number 3 are at equilibrium. Now, number 0 is above equilibrium. And number 2 is below equilibrium. And I could tell that they're both by the maximum amount. I know they're by the maximum amount because right after number 2, right after it goes below the equilibrium, the thing starts coming up again back to equilibrium, right? And I can even draw another to make it even more clear. And someone's here, hold on. Like I can even draw another one right here. So you can see the pattern in this one, in this example that I'm doing. You can see the pattern that at like once any mass is like away from equilibrium at all, the next mass is right at equilibrium, which means if you think about this picture, this is a picture from the videos, this is a picture from the introductory discussion on this, or maybe even from a lab. Like in this picture, you can actually tell, if you understand what's going on, you can tell that each one of these masses is advanced by literally exactly a quarter cycle from its neighbor. Like the very first one is not just above equilibrium, it's above equilibrium by the maximum amount. No mass ever gets higher than that. And so the 0th one is at amplitude. Then the first one is at equilibrium. Then the second one is at negative amplitude. And then the third one goes back to equilibrium, right? So like if you think about a mass on a spring or whatever, like from amplitude to equilibrium is necessarily definitely 1/4 cycle. Because what is a cycle? A cycle is a round trip. It means from amplitude all the way across to negative amplitude and all the way back to amplitude. That's a full cycle. So if these things were drawn, so if I went from amplitude to negative amplitude, that's a half cycle. If I go from amplitude to equilibrium, which is what these guys are doing, they're going from amplitude to equilibrium to negative amplitude to equilibrium to amplitude. Each one of these is separated by a half cycle. So each one of these is separated by pi over 2 radians. So the K value in this situation, which is not the practice exam, like this is, again, I'm trying to explain something. In this situation, it is clear to me that the K value, the value that comes right before X in the equation, that value that comes right before X in the equation, in this picture, K is pi over 2, which put in radians per meter. Every meter that we go across, we advance pi over 2 radians in the cycle. We advance 1/4 of a cycle. So now going back to the exam or going back in my thinking, I'm saying if I look at this picture, I'm familiar enough with what's going on at this point that if I look at this picture, I know the K that's being depicted is pi over 2. But vice versa, if someone wrote down an equation for me that said, could you draw this? And if they made their value, if they drew out this kind of equation right here, but they put in numbers into it, as we did in the exam, if they put in a number for K, and the number was pi over 2, I would draw my springs like that. And I would realize that really it would only take me like 4 springs to really be sure. Oh, I'm covering up, like you can't see the cover up on your screen. But if I covered up those, within 4 springs, I already see the pattern. I see what's going on, right? So if you wrote the equation for me and I had to draw, that's what I would draw. Well, going back to the private chat person's very fair question that that of course, as always, I'm saying I'm only going to sort of answer, but I'm like over answering. He or she asked, can I draw the diagram for the problem in the exam? So in the exam, so this is the equation, right? In the exam, if you look at the equation that was given to you, if you're starting to get familiar enough with that equation to know where to find omega and where to find K and where to find A in that equation, in the equation you were given in the exam, the K was not pi over 2. The K was pi over 4. So we're saying there's much less. So we're saying the increment in cycle stages between the stagger of phase value was much smaller. In your equation, it means the diagram has to be more elaborate. Like this diagram that I'm not telling you like is correct, but it's just an excerpt. I'm saying, like, notice we can go a lot more springs before we ever get to the equilibrium position, because each spring is not advanced a half cycle over the next. It's actually advanced an eighth of a cycle, if you think about it, based on that K value. So to really show that and really understand it, you got to draw. To those of you who are still listening to me or with me or haven't been bored to tears, yeah, I think you're starting to see, or you already did see, like why the problem says you got to draw at least 6 springs to see what's going on. And maybe you're even seeing, well, then why 9 would be even more ideal. Like you'll just get a glimpse of the pattern at 6 and you'll be really confident of it at 9. And you'll see why I'm not, so this is correct. The person who asked me for some of the diagram, like what I'm giving you is correct, but it's not complete. It's part of it. And you'll really understand, you'll know how to fill in the rest if you understand why I couldn't even draw the x-axis through any of my spring masses. Like I don't have enough spring masses to draw, I haven't reached equilibrium yet. So the x-axis is like way below what I'm drawing. But that's what I'm looking for. And finally, to wrap this all up, like I'm beginning to think that really what this exam is an exam of how willing people are to like sit in the mind-numbing like listening space of me. But of course, I guess that is what exams are anyway. Like who was listening in class? But excuse me. I will move on in a moment, although I would like to get confirmation from that person whether this was helpful or not. But I will say, basically, this is what I'm going to be looking for when I ask you for the diagram. But yours will be bigger. Yours will include more springs. And it will include all this information. But then ideally, again, like pro tip, I don't even know if this is a pro tip. This may be like a requirement. Once you've drawn everything out, you're going to label, like in your diagram, like point to things and have little footnotes or explanations of, here is how omega is clear in the diagram, or here is how K is clear in the diagram. Or put another way, here's how the pi over 2 is expressing itself in the diagram. Here's how the pi over 4 is expressing itself in the diagram. Like you want to make it clear to me that you know how to read that equation and turn it into this picture. And so every element that's in that equation somehow should be depicted in the diagram. So I'm going to pause for a second. Oh, okay, cool. Thank you. Thank you, direct chat person. Thank you. Okay. And I don't know if I answered the negative positive thing exactly, but I'm sort of going to assume until told otherwise that I sort of did, or that you retract the question based on. All right. So that's the diagram. These are good questions though. Again, I appreciate you're seeing how like you guys are asking questions of pretty much the right size. You see how I'm making them even bigger than they are, and you see why we can't just do a walkthrough of the whole thing. So I'm going to pause. I'm going to pause. I'm happy to go to another place or to another question. But yeah, but I certainly do think that emphasizing the part 3 of this exam is probably the best thing to do. All right, I'm going to pause for a second. And again, I'm going to do this thing. I'm going to pause. I'm going to wait for a couple of questions to come into the chat or raise hand, and I'll choose to do them in an order. So again, you're flipping through, you're seeing where you have issues. And again, the most ideal thing is like you tried something and you got into a jam and you're asking about the jam. Like, obviously, it's better to ask about something that you've actually tried than not, which I feel like is what has been happening. But so we're going to pause. Okay, so I'm looking. Okay, so we're pause. All right, I will pause. Yeah, I think it's bad. I'm gonna pause until, I'm gonna wait till there's more questions. Obviously, if you're just sitting there and working it through now in order to come up with questions, that's fine too. Like, this is not a test of the test, but I do think it's best that I respond to questions, not just talk. So I'm gonna pause until there's more, but you know.